Hi guys, today we are going to discuss about the convective heat transfer analysis of a 2D component. Let's discuss it in ANSYS APDL, Open APDL. Just maximize this. Select preference, thermal, okay. Preprocessor element type, add, edit, delete. So add the element, select solid, quad 4 node, okay. And in options we need to select the thickness, plane thickness in element behavior, okay. And close this. Go to real constants, add, edit, delete, select add, okay. And give the thickness as 1 in the sense we go with 1000, okay. And close this. And material props, material model, thermal, select conductivity, isotropic, K value, it is 10 units, okay. And close this. Go to modeling, create key points. uh, Either we can create key points or else directly we can create areas. So we'll go with inactive CS. So basically we need to design this. The design should be like this, okay. This is the design that we need to get. So here it will be 0 comma 0, it will be 0 comma 300, it will be 200 comma 300, and it will be something like that, you need to get the coordinates of the entire design, okay. 0 comma 0, 300 comma 0, 200 comma 300, I mean 300 comma 200, and this will be 500 comma 200. In that way we need to design. Let's go 0 comma 0, apply, and it is 300, and y is 200, apply, and this will be 500, and this will be 200, apply, and again y is 0, apply. Here one point need to come, so that is 300, apply, and then 500 plus 300, okay. So 800, 0, apply, and then that 800, and here it is 400, apply, and again 0, 400, apply, okay. The overall design required key points were designed, and then you can cancel this. So after this we need to get into areas arbitrary through key points. Select first point, and then fifth point, and then second, third, fourth, sixth, seventh, eighth, okay. This is how we need to create the area. Fine, that's it. And then we need to get into meshing. Mesh attribute, no need of mesh attribute. Select mesh tool, select smart size, and decrease it to 5 or something, and select areas, select pick all. Here the element edge length we can go with 30 or 40, okay. And the rise hidden, select mesh, pick all. So this is how the meshing will be. And then go to loads, define loads, apply, and the thermal. So here the way of application of loads, It is mentioned in the solution, define load, supply, thermal, temperature on lines. So we need to select the lines, and the temperature we should give is 300 degrees as per the diagram. Okay, so this base and this base, I mean this side and the internal side of the area, so we need to give 300 degrees of all these sides, and the top we need to give 40 degrees centigrade. Okay, and the heat transfer coefficient, it is 50 watt per meter square degrees centigrade. So first we need to select temperature on lines. Select this line, the side line and the upper line, and the side and the bottom. Okay, so here we need to select temperature, that is 300 degrees. Okay, and then the temperature again on the top, on lines, select on lines on the top. Okay, here we need to select all DOF at the same time. Temperature is, what's the temperature? It is 40 degrees centigrade. So 40 degrees centigrade. Okay, and then we need to give the heat coefficient, that is we need to select convection on line. Select the appropriate line, like the top line we need to select. Enter the film coefficient, we need to film coefficient, that is 50. Okay, so the top line we need to give film coefficient. Heat, okay, convection, in the convection we need to give on lines. Select this line. Okay, so here film coefficient we need to give, what is the value? 50. So film coefficient we need to give 50, and the bulk temperature is 100, no sorry, 40 degrees. Okay, that's fine. And we need to create some, yeah, that's fine, no issue. With this we can close everything off from preprocessor, and we can go get into the solution and solve current load step. Okay, so this is how you should get solution is done. And then general post processor plot results, contour plot, nodal solution. You need to get into the DOF solution, nodal temperature. Okay, so this is how the heat flow in a conduction way will be, I mean conventional way will be, we can see. And you, if you want to see it in a 3D view, just style, size and shape. In plot controls you need to select a style and size and shape. In that we need to enable this one, display of element, we should turn on. Okay, so this is how the 3D view will be, and then this is the oblique view. And if you want to see it in a query results, subgrade solution, temperature. Okay, you can view the temperature in this way. So 300, 251 and 200 and 100, and the top you can see the 40 degrees temperature. So this is how the heat transfer from the bottom to the top, it will be in this mode. Okay, and if you want to see it in an animated way, you can get into animate from plot controls. So in that animate you need to select deformed results. In deformed results you need to select the temperature. So this is how the animation will looks like. So that's it from this video. If you have any doubts, just comment below the video. That's it. Thank you.